Unless there are any more questions that Ryan wants to ask on this topic, I'm going to pass over to Ryan, because I know you have some questions potentially for Craig, and I believe Craig's joined us at this point.
Yeah, okay, so first of all, yeah, let's see.
I have, but I'm just going to change rooms.
Great, you are there, okay, perfect. Okay, all right, great to talk with you, Craig. I didn't see your video when you talked just now. Could you say something again and see if we see your video?
Okay, can you hear me properly?
Okay, perfect. There we go. Now I hear you and see you.
Good.
Okay, excellent. Okay, all right. Well, Craig, thanks for
that right, because I can't actually see my screen on the thing. So.
Oh, okay. All right, that's unfortunate. Okay, you can hear me though. That's.
I can hear you. I can see you, but I can't see me. So I don't know whether I've aimed my camera.
Yeah, there's. I noticed the same thing. We're. I don't know. We'll have to fix that in a future webinar here because I can't see myself either. But well, thank you for joining us, Craig. And I've got a bunch of questions for you. So we figured what we're doing here is because we implemented this peer-to-peer thing between MoneyButton and Handcash. So we have a bit of peer-to-peer going on. As they were just explaining, I'll just give a bit of background so that people understand a bit more technically what it is that we've done, because that just came up. What we're doing is actually giving the transaction itself person to person inside these services. So, you know, the end user on one app produces a transaction and delivers it to the end user on the other app. So we're referring to this as peer-to-peer. Now, this is not full SPV in that we're not currently delivering Merkle proofs. The reason why we're not doing that is basically that we didn't need it yet. What we wanted to do right now is basically solve a first problem, which was creating a more scalable infrastructure, but we will ultimately need to deliver Merkle proofs to have proper SPV. So I just wanted to explain that brief technical background. But Craig, let me ask you at a sort of higher level. I'm going to start with a very, very high level because the white paper is extremely relevant here in being, clearly, explicitly writing about peer-to-peer. First of all, Craig, did you write the white paper?
Well, I typed it, so.
Okay, so if you type the white paper, you probably know something about.
Probably most of it, I actually talked to a computer, and the computer typed. But...
Okay, really interesting. Okay, so can you tell us then? I mean, there's a lot I could say about this, but I really would just rather you tell us. I mean, what is the white paper talking about when it talks about peer-to-peer?
So it's talking about two different areas. So I'm talking about a peer-to-peer verification network, which is a more traditional sort of highly interconnected system of machines that will verify. But on the other part is a separate network, which is a group of users who basically hand transactions from one to each other. And the original design was such that people should be doing IP to IP or peer-to-peer type transactions. Now, that actually allows it to scale better, and it's more private. You can have other messages. Not everything needs to be on chain. This is where people go wrong. They keep going, I need to put everything on chain. I don't. I could put a hash of an invoice, but have a contract and everything like that saved separately. Maybe I want to then encrypt it and save it myself, but I can choose how I do that.
Okay, so I think this is something important that many of us didn't fully understand originally in the white paper, though. I mean, you're saying very clearly there are two different networks then, correct? In fact, could I just explain it and see if I say it in a way that you think is correct? I mean, really the miners have their own network in that they're communicating each other. They're communicating transactions and blocks to each other. The users can connect to the miners, but the users also connect user to user. So when I send a transaction to another user, I don't necessarily send it to the miners. Now, somebody sends it to the miners eventually. But they're two different networks. They're connected, but they're different. Is that correct?
Yeah, so in the early days, really the registration network would be something completely different. Generally, that was the centralized server who kept an authority to stop double spends. Now, Bitcoin is a token system. It has individual, indivisible, fungible digital tokens. There are 100 million individual tokens, and these are not put in addresses like people think. They're put in, think of it as a virtual envelope. So you get your little like pieces of rice. Imagine that each token is a piece of rice, and you drop it in your envelope, and you seal up that envelope, and then you post it into someone's the address or script would be the equivalent of a post box. And I can have lots of individual groups of these tokens in my post box. They're effectively envelopes full of tokens. Now I have to rip open and destroy that UTXO or envelope every time I want to do a transaction. But that doesn't mean that I rip apart every envelope in my post office box. Now, when I'm doing a transaction with you, I'm actually giving you my tokens. They're virtual, so it's not like I've physically handed you tokens, but I'm doing an exchange. And those tokens now go to you. Now, you want to make sure that no one steals them. So the first thing you do is you go to the miners and go, I'm registering my sale. The same way as if I buy a car or a house. If I'm the buyer, I care. When I buy your car, I'm going to run to the sort of registry and make sure that that gets filed. When I buy your house, I will run there and get it filed. And that's the distinction people don't get. The buyer should do that because they're the ones who care. The seller doesn't care.
Okay. Are you describing who gives it to the miners? I'm not sure I understand what you're saying there, because I thought I had it the other way around. When you say the buyer, what do you...
I mean, as in I've received the token. So I've bought my Bitcoin from you. Sorry, I should... So thinking of it as digital grains of rice, but really what I'll end up doing now is taking that and making it cash. And what people don't understand is that's where things like gold and everything came from, and where cash came from, where you talk about weight units of grains. So if you've heard about like how many grains of gold, it goes back because we're actually talking about these things in wheat and barley and everything like that. So people have forgotten the origin of the words and they get it wrong. So talons of silver are a weight of wheat. And that's where people don't realize that these are weight units for a fungible commodity, and that's the origin of money.
Okay, that's very interesting. What is the relationship of Bitcoin to money in this perspective? And you're looking at like grains of rice. I mean, is it supposed to be, is it treated like money? I mean, explain that relationship there. Okay,
so then Bitcoin is cash, and cash is only one part of money. It doesn't replace all of money. So it's not debts, it's not banks, it's not anything else. It's cash. Now, what cash is a representation of a one-to-one relationship with some item or whatever else. With fiat money, it's a representation of a one-to-one debt obligation to the government. You can pay your tax obligation one-to-one with US dollars or pounds or whatever else. With wheat, where grains and all that stuff and talons came from, it was, I could get this amount of wheat from the silo. Now, Bitcoin is the same. I have these tokens, and they represent a certain right for a number of tokens that are basically set on the blockchain. There can't be more. You can't divide them past the other. There's no fractional tokens. It's not an account-based system. It is literally a number of tokens. And each token, although they don't have much value individually now, gives you a right to write an individual entry at a time.
Okay, I think I understand. I mean, I get it. These debt instruments and things of this sort are not the cash. These are other parts of some greater system of money that we include.
They're a greater part of money. So it's not just M0, M1, M2. Cash is actually more specific than any of that even. It's not just sort of cash accounts or anything like this. It's actually the amount of one-to-one debt. And it's still a debt. It's, I own that grain. I have this tally stick that says, you have to give me that grain. But the difference is you can't fractional reserve cache.
Okay. I want to ask a couple of somewhat technical questions related to this notion of peer-to-peer. So something that you've mentioned in the past that I thought was extremely interesting and made me think about things differently was the usage of IPv6 in all this stuff. Can you maybe explain how should we be sending these transactions peer-to-peer? Do you have a technical opinion on what is the right mechanism to actually send transactions user to user?
So I would like to see more use of IPv6. There are a lot of benefits with it, even with it being stripped down. There are things like CGA++ or cryptographically assigned addressing. There's IPsec that can be automated, all of this sort of stuff. And people don't realize just how widespread IPv6 is right now. So the majority of machines connected to the majority of ISPs actually end up with an IPv6 address now. Most of your phones do, etc. Just we don't even realize it. All the major websites and things all have IPv6 enabled. IPv6 Day happened over a decade ago, and like 80% of the internet at that point was all connected, and it's growing. So we have this mechanism that will allow us to add privacy, have better routing, have not having to have, this SSL TLS layer wrapping IPv4 that will allow us now to connect end-to-end using the existing certificates and everything that we can create in Bitcoin. So imagine now that we can actually link something simultaneously to our Bitcoin master certificate and a group of keys, and knowingly know that no one has interjected or done a man in the middle, monkey in the middle, whatever you want to call it, into our communication. So that may not have been in IPv4, but I've been talking about this since 2011 anyway, where you can start actually building integrated networks. And there's no separate VPNs required. There's the ability to have privacy. If you're talking about things like cryptographically assigned addressing, then you have a 48-bit address range where you move around from on any network that can be provably pseudonymously linked back to your sort of identity, where your ISP or your business can actually still link it back to you, but the world can't. So there are all these benefits that most people have no idea about, because if they're coders, they're not network people. If they're network people, they're not engineers and business people, and ...
Yeah, that's definitely true. So we need to create a sort of full scope of education about all these things so that people can understand everything together. I have another sort of technical, I basically have a sort of an idea here based on what you're telling me. I mean, so let me briefly explain Paymail and get your thoughts on something, because there's a sort of related problem here. So there's basically the problem of names. So the problem of how do I, if I go to a domain name, we use DNS, we have the ability to connect a name, the domain name, to an IP address and visit a website or do whatever else we want to do. One of the problems we solved with Paymail, I should say we've got a solution to, is a naming problem, which is giving the end user a name, or it could be a device or something like this. So you can connect to a name rather than IP address. Is naming something that you have thought about? Like, what is your opinion on how do we manage names, basically so that the end user ultimately doesn't actually have to type in an IPv6 address, which looks like a bunch of random looking characters?
It is something I've thought about. The difficulty comes down to things like DNS and whatever else. I've written in the past about sort of Unicode and other things. One of the reasons for base 58 is you can't really do a Unicode attack on it. There's no funny Greek A's or Cyrillic O's or anything like that that look exactly the same, that allow people to have these embedded websites that look like Microsoft.com or look like Google or whatever else, and enable people to have sort of really good spoofed accounts. So what we need to start doing is the integration of better identity as well. So it's not just linking the person to that, but being able to then have that person give out sort of access and rights to devices on their network, to other things, so that I could say Craig's phone, Craig's computer, and then have a whole lot of subgroups that I can own.
Well, that's exactly what so we sort of do that with Pmail. So we have these names at a domain name that looks just like an email address. I mean, have you looked at that? Do you have an opinion on, like, basically? Okay, what do you think about that solution? Is that a reasonable solution there?
It's a good start. I still think we need to move forward into being able to have people registered properly at the same time and be able to provably, I mean, even as a pseudonym, if you want to run a pseudonym, I have no problem if people want to deal with it as long as they know. But being able to sort of have proof of real person and things like this.
Yeah.
So,
yeah. Okay. No, I totally, yeah.
But that's a bigger, different issue. So
that's part of the full scope of a real complete solution to identity. An idea that I had while you're talking is we could add a new Pmail extension that would actually be an IPv6 address. So imagine if, say, a user is a Handcash wallet user, and they want to receive their transaction. They would actually communicate device to device. If they could register their current IPv6 address with Pmail, it'd be possible for a third party to query, find their current IPv6 address, and then communicate actually device to device if the devices are all using this IPv6 world. That would be something we could do to bring to add a sort of IPv6 version of this sort of peer-to-peer stuff on top of Pmail.
So one of the things people don't seem to realize is that IPsec has the equivalent of firewall rules built in. You can actually set IPsec up to allow any, deny any, allow to this site, deny to this site, allow encrypted, deny decrypted, those sort of things. Now, if I can start doing that, I can put these policies not only on my machine here, but I can push it out to mobile devices and endpoints and things like this, which was one of the big areas I was looking at as well. So imagine we don't need VPNs anymore, but anywhere that my mobile goes, as part of this, I can use the same integrated sign-up and the same communication methods and the same tokenized payments to access my business and my other things, allowing me to actually say, all my insecure internet will go through this proxy and be secured. All of my company stuff will be open in the company. And rather than a crunchy shell model of security, we can start moving to sort of a virtualized company.
Okay, I want to create some brief background material for people because I'm worried we're probably losing some people in the audience. So for people to understand, IPv6 is like a newer protocol for the internet. What a lot of the internet uses right now is called IPv4. And what Craig is referring to is this idea that often you might have on a personal device, you're worried about security. You don't necessarily want to expose your personal IP address publicly. There are various ways this is dealt with firewalls and things like this. There's also have to worry about things like end-to-end encryption. Craig is basically saying IPv6, this new protocol, has a lot of this stuff built in. It has the some firewall thing, which I didn't understand that or know that before, but that's built in, as well as things like IPsec, so you can do end-to-end encryption and things like this as well. So you're basically saying, and see if I'm getting this wrong, but I mean, this is most people. This is so beyond normal end users; they don't think about these things. But this really is a far more advanced protocol for the internet that we can leverage all this stuff to allow end user devices to really directly connect to other devices in a way that is either not possible or impractical for these reasons using IPv4. So it really is a better solution. I hope that we can iterate towards that on the internet.
And we're not running out of it either.
We don't run out of address space. That's correct. There's plenty of IPv6 addresses for every single device. What is your opinion on the timing there? You say it's already more widespread, and I think that's correct. Like, I'm pretty sure many times when I use my phone on the cellular networks, I get an IPv6 address. What is a realistic time frame, though, for like the world? I mean, maybe it's already good enough that we can start building some applications. I will say, though, that we did look into this when we were originally creating Pmail. We really wanted to do IPv6. A year ago, it seemed like it wasn't big enough to really start doing it right away, though. Do you have an opinion on timing to really integrate this in a serious way into Bitcoin wallet software?
There are things like Teredo and 6-to-4 over HTTPS. So it's fairly much open anywhere. Windows has supported Teredo since XP. And it was a big thing that I used to always have fun with sort of security audits and things like that in the past, where you could, like all these people would think their firewalls were safe. And you can actually natively in XP, which was unlocked down, get IPv6 out of most firewalls in the world, big corporate ones, government ones, whatever else, because no one even realized it existed. So Teredo, T-E-R-E-D-O, is an old sort of gateway tunneling protocol for V6 to V4. And these things are there. It's just, I mean, this is the problem. There's all this technology there, just no one seems to know about it.
I think no one knows about it. There's a bit of an incentive issue too, where like when things are working with IPv4, there's if you don't fully understand it or appreciate the future here, there's a bit of a sort of slowness to migrate to IPv6, because IPv6 has been, I don't know when it was created, but it was at least 20 years ago, I'm sure. I mean, it's been rolling out on
25 or yeah.
Okay, so yeah, it's like taking forever to migrate everything to use IPv6.
But it is actually most of the backbone. That's what people don't realize. I mean, all the big companies, Google, Microsoft, whatever else, are all sitting on this.
Yeah.
BT over here, Hurricane in the sort of states, etc., all sit on this. Just most people don't even know that they have it. And, well, you don't want to type it in. I mean, if you look at the difference between a 128-bit number and a 32-bit number, it's much friendlier to type in a 32-bit number. So the nice little simple 4-octave IPv4 thing people remember. But I mean, I've got several /48s and /64s that are assigned to me and my companies, and I have no idea what they are.
Yeah.
I mean, it's just there's too many things to remember. So even when you own the damn things, you don't know them.
Yeah,
I definitely get lost seeing addresses like this. I have one question, if you wouldn't mind me jumping in, Ryan. I'm curious about the using Bitcoin as a sort of data transport mechanism. So over the last year, app developers like myself have been using op-return, and now obviously push data and things like that are available. Could you maybe explain what the advantage of potentially using a Bitcoin transaction as a wrapper around data, even if we are using IPv6 to transmit the data and sort of secure the data, is there an advantage to wrapping it in a sort of Bitcoin transaction?
Yes, we could have micropayments, payment channels, and actually have things that are sort of commercially costed at all levels. Now, even if they become subsidized by payments between ISPs and things like this, that now allows you to put a tokenized cost on things. So you can start working out where your different protocols cost most, when they're going to hit most. Should I charge Netflix more, especially during COVID, because, well, they're getting hammered? Should I allow access to Library of Congress? Those sort of things.
That brings me to a question that one of our audience members has asked, which is how you think that BSV might be able to contribute to helping our current situation in lockdown.
Current one, I don't know. We won't. I mean, we don't have enough time before this ends. Hopefully, I mean, the reality is it's going to have to end soon, or we're all going to starve to death. So at least we won't die from COVID when we starve. Yay. Sorry, I had to throw that in. I mean, once this insanity ends, then we get into sort of where hopefully we can start tracking people properly. So I've been working on some solutions that I won't discuss quite yet, but right now everyone like Google is coming out with these horrible lack of privacy apps, where basically Google was being sued by the European Union, who were actually contemplating splitting Google up and making lots of small Googles. And now they're going, save us, Google, save us. And I mean, this has been great for companies like Google, who've just saved their ass from actually being destroyed. And now instead they're coming out, they're going, hey, George Orwell had a great idea in 1984. Why don't we implement that on everyone's phone? And I mean, it's horrible. I mean, there are better ways of doing contact tracing without actually knowing who people are. So there are technologies that will allow us to actually record pseudonymously that you've had. You don't care who you have contact with. You care that person X is recorded and you have contact with person X. You don't care. And the government shouldn't care that you have contact with person X. It's just a pseudonymous thing saying, I have been in contact with someone that is recorded as having COVID. I better get tested. Not, oh, I better give you a list of everyone I've met because, well, after all, the government requested it. And this is an age of pandemics, so I shouldn't have privacy anymore. And that's the problem I'm starting to see. People are not understanding that their freedom, their privacy and everything like that is what they'll give up. And it's going to be a big cost if we do that. So we can start recording information in a way that no one can cheat on. So if we have an immutable blockchain that records everyone that you've met, but it's just a randomized ID, and we can calculate person X gets tested and they broadcast to everyone they've met. They don't know. I could have passed you on the street and our devices can do an exchange without doing identity. And that'll become important.
Very interesting. Ryan, did you have any more questions you wanted to ask? Otherwise, I can take some from our email questions.
Let me ask one other slightly technical question, but I'm just curious Craig's opinion on this. So basically, how can I put this? You know, with Paymail, we're using these traditional internet technologies, DNS and HTTPS. Do you have an opinion technically on the right way to manage names? Like, do you imagine, Craig, seeing some type of on-chain naming system, like putting DNS on-chain or maybe just having nothing to do with DNS whatsoever? What do you have a technical opinion on how to deal with names when it comes to Bitcoin and identity and things like this?
DNS is simple and works, but I'm old school and I still actually like X500, which shows how old I am, which most people don't even realize that they still use sort of the remnants of it. When you do /UK or /US, that's the country code is from X500. And then you've got the other entity codes and company codes and everything like that. So when you register an SSL certificate or a TLS certificate, that's still all there in the background. It's just everyone forgot about it in moving to the internet. And if we could formulate a way of getting that sort of level of identity and country and everything like that, while also allowing people to have some sort of pseudonymous identity. But I think to be successful, a pseudonymous identity needs to be something that can be registered as pseudonymous. So if I have my real identity and I prove that, then that should be separate from a pseudonymous identity and people should be able to choose between the two. I don't think I should be able to fake a pseudonymous identity that looks like a real identity and fool people, or then we get a whole lot of problems. But most of us are happy to deal with someone in a shopping center without knowing, hey, what's your social security number, Bob? I mean,
got it. Okay, that's it for me, Darren. If there are more questions from the audience, maybe we can go through any remaining questions from the audience.
Great. I'm struggling to find super relevant questions on this particular topic for Craig specifically. I have a question here from Brendan Lee, though, that's a little off topic. But Craig, you've spoken, I'm quoting Brendan here, you've spoken of building a television from parts with your grandfather as a child. I read somewhere also that you made a pencil from scratch and have many certifications in practical art, such as vehicle mechanics and others. Would you say that this desire to understand and partake in the design, construction, and repair of so many varied everyday items at a component level formed a part of your inspiration to re-engineer money at such a fundamentally basic level? It's from Brendan Lee.
Definitely. I actually am one of these people who not only like to pull the telephone apart, but to put it back together again, hopefully, and have it work. I don't feel comfortable unless I sort of pull things apart and understand them. And I've felt that way for a long time. It's probably a little bit of my Asperger's and whatever else, but I actually like to really understand things. So whenever I get involved with something, I have this sort of insane obsession where I have to go into annoying details and find out everything about it.
That makes sense. Great. I have one more question that's really to do with the, Alphabet and other companies like that. So for example, Alphabet's advertising revenue comprises about 85% of its total. Facebook's is more like 98%. So Jacob Pudgley has asked, what do you think will be the Osnap moment besides micropayments for the big evil corporations to drop this ad-based revenue model and move away from the sort of dangerous algorithm sorting of content, sorting and blocking of content?
I don't think there's going to be an whatever movement until they see money. So the irony here is all of them started going, advertising is evil, we don't want to do evil. And now they're going, that's fine, we're making money. And I mean, Google, do no evil. Well, do a little bit of evil. Whatever. I mean, it sort of moved as, well, if you do evil, you can get the yacht. Yeah, that's a nice yacht. Yeah. Exactly. So it's going to really need to be some competition out there. So when they start seeing that they can do this and make money, that's when it's really going to kick off. So Facebook are on Libra or Facebook coin version 5 at the moment, because they've actually been trying this for a long time. I mean, Microsoft were even involved back in the 90s, apart from David Shaw was a terrible businessman and wanted a big chunk of Microsoft for them to use eCash, which really killed it. It was I mean, there are plenty of good deals you can do. Saying I want to have a third of Microsoft is a stupid one. Hi, I've got a new technology. Give me your company. Yeah.
Right.
But I think it's really going to, it'll change when someone comes up and shows that the idea can work. And once they can start doing that, then someone can start really integrating something that doesn't sell everyone and sell their lives. But right now, too many people are just, they're used to advertising. They're used to not caring. So
comfortable making the money, presumably.
Well, even users, none of us complain anymore. I mean, I try and click, no, I don't want cookies on most things. And yeah, but most people just don't even put the option up these days.
Awesome. Well, thank you so much for your time, Craig. We're going to move things on to talk a little bit more about Invisible Money Button with Eva from Money